All right, section 11.3, we're talking about acceleration. All right, what is acceleration? So we've talked about two things so far. We've talked about distance and displacement. Remember, distance is your overall amount that you've traveled. Displacement is the distance between your starting point and ending point. Speed was the rate at which you're changing distance. Acceleration is the rate in which you're changing speed. So if you are changing speed, you are changing acceleration. Now, remember, velocity was speed with direction. So velocity was a vector. Acceleration is also a vector. So when you say acceleration, you have to apply a direction to it. So when we talk about changes in speed, that's what we're talking about acceleration. The car sped up. Well, if the car sped up, if you think of like a dragster, you go from 0 to 200 miles per hour in like 4 seconds, right? It's increasing in speed. Well, what we like to say is it's accelerating. It's changing its speed very quickly. So if you're increasing your speed, if your speed is always changing, you're accelerating. Now you can positively accelerate and you can negatively accelerate. Think about it. It's called deacceleration. What happens when you hit the brakes on your car when you have a stoplight? You go from 50 to 0 in a handful of seconds. You're deaccelerating because now you are changing speed, but you're slowing down. So it's possible to speed up and to slow down. But anytime you have a change in speed, it's going to be called acceleration. So once an object stops accelerating, it maintains a constant speed. So if you are driving down the highway on cruise control at 55 miles per hour, is your speed changing when you're on cruise control? No. If your speed is staying the same, is it changing? No. If your speed is not changing, do you have any acceleration? No. Acceleration only happens when your speed is changing. So something to think about. Your acceleration only happens when your speed is changing. So how do we calculate acceleration? Well, it's going to be calculated by taking the change in velocity and dividing by the total time. So now we're going to expose you to a new unit. So here's our new equation. We have acceleration is equal to triangle V over T. What does triangle mean? Triangle means change in. All right. Triangle is the Greek letter D, or delta, and it stands for change in. Anytime you see change in, you can think of you're going to take your final velocity minus your initial velocity. So if you wanted to rewrite this equation as acceleration is equal to final velocity over initial velocity over t, this equation is the same exact thing as this one. All right? But the difference is we just abbreviate with the change in v. So change in v over t is equal to acceleration. Now, what are our units for acceleration? Well, our units typically are going to be meters per second squared. Meters per second squared. Now, why is that going to be? Well, you're having change in velocity divided by time. All right? So you're having change in velocity divided by time. So if you take your units and divide them out, we're going to have meters per second divided by seconds. Now, remember when you divide fractions, you can multiply by the reciprocal. So meters over seconds is the same thing as meters over seconds times 1 over seconds. And when you get that, you get meters over seconds squared. So just showing you the units for acceleration. Meters per second squared typically. Sometimes it's kilometers per hour squared, but just kind of giving you an idea of what the units of acceleration are. So if we have to go through and look at an acceleration problem here, let's do an example. A ball rolls down a ramp starting from rest. After 2 seconds, its velocity is 6 meters per second. What is the acceleration of the ball? Well, again, acceleration is equal to Vf minus Vi over t. We're going to need all of these things to solve for this. Acceleration is what we're solving for. So we're going to put acceleration is equal to a question mark. Starting from rest. So what is our initial velocity if we are starting from rest? 0 meters per second. After 2 seconds, it tells us our time. After 2 seconds, its final velocity is 6 meters per second. So its final velocity is 6 meters per second. Now I'm going to go ahead and plug everything in. Acceleration is equal to 6 minus 0 divided by 2. That's equal to 6 divided by 2. And 6 divided by 2 is 3. What is the unit for acceleration that we just got done talking about? 3 meters per second squared. So acceleration is the units for acceleration are meters per second squared. The unit that we use for acceleration, the unit we use for acceleration is meters per second squared. The definition of acceleration is simply the rate at which speed is changing. So if speed is changing, you can have acceleration. That is the end of section 11.3.